Hey everyone, so today let's solve check if n and its double exist. You're given an array of integers. You need to find if there are two elements at different positions where one is exactly double the other. So if the array has 10, 2, 5, 3, the answer is true because 10 is double 5. If the array is 3, 1, 7, 11, the answer is false. No element is twice another. Now the brute force approach is straightforward. Check every pair with two nested loops. For each element, scan the rest of the array, looking for its double or its half. That works, but it's O of n squared. For large arrays, we need something faster. Here's the smarter approach. We use a hash set. As we go through the array, one element at a time, for each number, we ask two questions. First, is double this number already in our set? Second, if this number is even, is half this number already in our set? If either answer is yes, we found our pair and return true immediately. If not, we add the current number to the set and keep going. Why do we check if the number is even before looking for its half? Because if a number is odd, dividing by 2 gives a non-integer, and that can never match an integer in our array. So we skip that check entirely for odd numbers. Let me walk through this with a concrete example. Take the array 7, 1, 14, 11. We start with an empty hash set. First element is 7. Is double 7, which is 14, in our set? No, the set is empty right now. What about half of 7? Well, 7 is odd, so its half would be 3.5. That's not an integer, so we skip the half check entirely. No match found. We add 7 to the set. Set now holds 7. Next element is 1. Is double 1, which is 2, in the set? No, we only have 7 in there. 1 is also odd, so skip the half check. No match again. Add 1. Set now holds 7 and 1. Next up is 14. Is double 14, which is 28, in the set? No, we don't have 28. Now, is 14 even? Yes, it is. So we check. Is half of 14, which is 7, in the set? Yes, 7 is right there. That means 14 is double 7, and both are in the array at different positions. We found our pair. Return true. We never even reach 11. The moment we see 14 and find 7 already in the set, we're done. Now here's an edge case worth thinking about. What about zeros? If the array has 0, 5, 0, it should return true because 0 equals 2 times 0. Our approach handles this correctly. When we process the first 0, we add it to the set. When we reach the second 0, we check, is double 0, which is 0, in the set? Yes, from the first time, so we return true. The two zeros are at different positions, satisfying the requirement. Time complexity is O of n. We traverse the array once, and each hash set lookup and insertion takes O of 1 on average. Space complexity is also O of n in the worst case, since we might store every element in the set before finding a match or concluding there is none. Found this useful? Master key interview patterns at AlgoMonster and land your dream job.